Hello students, in this video we are going to go over all practice problems for the chain rule topic. Alright, let's get started. So let's start by example 28. So I want you to use the chain rule to find dc by dt. Well, of course, as I suggested in class, so when you do the chain rule problems, so you should draw a diagram. All right, so question 28.1. We have c equal to x squared plus y squared plus xy. Well, you can see that c is a function of x and y. And then x is equal to psi t. So x is a function of t. And y is equal to e to the t. So y is a function of t. So once you have the diagram here, so you can see that if you want to differentiate c with respect to t here, so by the chain rule, you're going to get curl c by curl x times dx by dt, and then plus curl c by curl y times dy by dt. Well, the diagram going to help you in terms of, you can see that, hey, start from the top level here, you can go to t via x, or you can go to t via y, right? So you have two ways to reach t on the bottom level. So that's why you have two terms here. And then after that, you just need to differentiate. Differentiate c with respect to x, so you get 2x plus y, right? And differentiate x with respect to t, so you get cosine t. Differentiate c with respect to y, so you get 2y plus x. And differentiate y with respect to t, so you get e to the t. And that would be the answer for question 28.1. That's it. All right, so for question 28.2, all right. Well, if you see the question, you can see that this is c equal to cosine x plus 4y, x equal to 5t to the fourth power, y equal to 1 over t. So you get the same diagram. Well, that means the formula for dc by dt, this is going to be curl c by curl x times dx by dt, and then plus curl c by curl y, and then dy by dt. The same thing, right? And then now you differentiate c with respect to x. So look at that. You have c equal to cosine x plus 4y. You differentiate with respect to x. So you get differentiate cosine. So you get negative sine, right? And then actually you have to differentiate inner function. So because the inner function here, you have x plus 4y. So you have to differentiate x plus 4y with respect to x as well. So once you differentiate that, so you get number 1. Well, you have number 1 attached with that answer. All right, and then dx by dt. So, well, I'm going to use the highlighter to uh, make sure that you understand and follow my answer here. So the one that I highlight in light blue here, this is complete. So the next one is the one that I highlight in orange, the x by dt here. So you differentiate x with respect to t, so you get 20t cubed. All right, good. And then the next term, you differentiate c with respect to y, so you get negative sine x plus 4y. And the inner function gonna give you number 4 here because you differentiate x plus 4y with respect to y. And then the last term, dy by dt, you differentiate 1 over t with respect to t, so you get negative 1 over t squared. All right, and that would be your answer. So if you want to simplify a little bit, so you get negative 20t cubed sine x plus 4y, and then plus 4 over t squared sine x plus 4y. All right, that is the answer. Well, pretty simple for this question. Well, I hope you find this is easy for you. All right, next we move to example 29. So for this question, I want you to use the chain rule to find curl C by curl S and curl C by curl T. All right, so you need to find two things. All right, keep in mind. And then, well, you have two sub questions, 29.1 and 29.2. So let's start by 29.1. So again, we have C is a function of U and V. U is a function of S and T. V is a function of S and T. So you obtain the diagram. C is a function of U and V. U is S and T, and V is a function of S and T. So when you do the chain rule, for example, 29.1, so you're gonna get curl C by curl S here. So you're gonna get curl C by curl U times curl U by curl S, and then plus curl C by curl V times curl V by curl S. Well, you can look at the diagram and you can see, hey, to obtain curl C by curl S, you have to start from C and go to S. That means you can go two ways in the picture there. So, and that can be replaced by the formula you see here. All right, now we differentiate C with respect to U. So differentiate tan U over V. So differentiate tan, you get secant square U over V, right? And then after that, you need to differentiate inner function, which is U over V. U over V, you differentiate with respect to U, so you get 1 over V. Does make sense? And then differentiate U with respect to X, so differentiate U with respect to S, so you get 2. All right, so the next term, you get secant square U over V again, but this time you differentiate with respect to V. So that means you're gonna get U times negative 1 over V squared. All right, and then differentiate V with respect to X, S, so you get 3. All right, sounds good. And then after that, you have 2 over V secant square U over V, and then minus 3U over V square secant square U over V. Well, this is the answer for question 29.1. You can see it is not that hard. It is just you have to be careful and perfect with single variable calculus, because sometimes you have to use a chain rule for single variable calculus inside the answer. All right. Next we have question. Well, we're still on 29.1, but we're gonna find another one. So we need to find curl C by curl T here, which is curl C by curl U times curl U by curl T, and then plus curl C by curl V, and then curl V by curl T. All right, curl C by curl U is what? So this is differentiate. Well, the same thing as before, so I can copy that term, because this term we can copy on the top, because we have, differentiate C with respect to U, we get that thing. So here, so we just copy the same thing. And then differentiate U with respect to T here, so I get 3. And then the same thing as before, so we have secant square U over V, and differentiate U over V with respect to V, so I can pull out U, and then I differentiate 1 over V, so I get negative 1 over V square. And then for differentiate V with respect to T, so this time I get negative 2. All right, so I simplify everything, so I get 3 over V secant square U over V, and then plus 2U over V square secant square U over V. All right, simple like that. This is super easy, right? Super easy, huh? This is, I hope you find that this is not that hard for you. All right, so, well, I'm gonna skip question 29.2 here, because you can do the same thing as question 29.1, but I will give you the answer for question 29.2. If you don't get the same answer as I show you in the clip here, so you can email me for more help. So this is the solution for question 29.2. So the solution is differentiate C with respect to S. So you're gonna get e to the x plus 2y times 1 minus t, 1 over t minus 2t over s squared, right? This is the answer for question 29.2, and deficiency with respect to t. So you get e to the x plus 2y times negative s over t squared plus 2 over s here. All right, so do question 29 by yourself, and if your answer is not the same as me, so let me know. All right, that is question 29. Sounds good. Well, we move to the next one, which is example 30. So example 30 here, we have something more fancy here. So let's look at that. So for question 30 here, so we have f, a differentiable function of x and y. So f is a function of x and y. All right, and they also give you that g uv is equal to f e to the u plus psi v, comma e to the u plus cosine v. Well, this notation make you confusing, but you can look at this notation and this is your f. So that means, well, this is a function of x and y. So basically you can let x to be the first term, e to the u plus psi v here, and you can let y to be e to the u plus cosine v here, and everything gonna be a lot easier. So we're gonna let x to be e to the u plus psi v, and then we let y to be e to the u plus cosine v. Well, now you can see that x is a function of u and v, y is a function of u and v. And this is a diagram that you have. Well, the table is given here to just give you some values, and at the end you need to plug in the numbers from the table into your answer. All right, so let's look at what they ask. So the question asks you to calculate g subscript u at 0, 0. So what does it mean by this thing? So g subscript u at 0, 0. This means you have to differentiate the given function g with respect to u, and you evaluate at 0, 0 at the end. So basically they ask you to compute curl g by curl u, and you evaluate at uv equal to 0, 0 at the end. This is what they want. So you can see that, hey, you have a diagram here. Well, the whole diagram here gonna call g, right? Because g is like a function of uv, and the whole diagram here is called g. And you can see that in order to get g, well, which is the same level as f on the top here, in order to get g on the top level to the u here, so you can go two ways, by x and by y. So that means here you're gonna get, well, I'm gonna start by compute curl g by curl u first, and then I'm gonna plug in the point uv equal to 0, 0 at the end. So here you're gonna get curl f by curl x times curl x by curl u, and then plus curl f by curl y, and then curl y by curl u. All right, this is because you look at the diagram here, you have f with respect to x, and then x with respect to u, and then f with respect to y, and then y with respect to u. Good. And then after that, you can evaluate this thing at uv equal to 0, 0, right? That means gonna be curl f by curl x. Well, because f is a function of x and y, so you have to make sure that when uv equal to 0, 0, x, y equal to 1. So if u equal to 0 and v equal to 0, then x is e to the 0 plus psi 0, which is 1. And then y equal to e to the 0 plus cosine 0, which is 2. So that means when uv equals to 0, 0, x, y is going to be 1 and 2. All right, and then curl x by curl u here, and this is at uv equal to 0, 0, and then plus curl f by curl y here, and that is when x, y equal to 1 and 2, and then times curl y by curl u, and then that is when uv equal to 0, 0. All right. Well, just long notation, but the concept is not that hard. All right. So the first one, differentiate f with respect to x at x, y equal to 1, 2. This is 2 because, well, you can see in the table that f subscript x is here that I highlight in orange, and then I evaluate at 1, 2 here, you get number 2. All right, and differentiate f with respect to y, which is f subscript y. Well, at 1, 2, I have 5, so this number is 5. Well, but for x, the term here, the second term here, that differentiate x with respect to u here. So what I get is I can just start from x, and then I differentiate with respect to u. I get e to the u, right? And then I plug in u equal to 0. Does it make sense? Because you have x equal to e to the u plus psi v. You differentiate x with respect to u, so you get that. Well, the same thing, I differentiate y with respect to u, so I get e to the u as well, and then evaluate at u to the 0. Well, if you compute everything there, so you're gonna get 2 times 1 plus 5 times 1. So the answer for this question is 7. Sounds good? Well, this is uh, the way to compute example 30. So, well, it is a little bit tough because the notation looks crazy. But once you understand the notation, well, everything should be easy, right? Well, I'm gonna leave the second part for you, but well, I will give you the answer here. If your answer does not match with my answer, well, let me know so I can explain to you more in details. Well, but if you compute the subscript v at 0, 0, this is the same thing with curl G by curl V at UV equal to 0, 0. Well, if you compute that thing, the answer gonna be 2. Well, trying to copy the same concept as I show you here. Well, and then you just change the function and the number a little bit, so you get the answer on the second part. Well, that is example 30. All right, we're gonna move to the next one. Example 31 here. So I want you to use the chain rule to find the indicate partial derivative. So this is the case that you will see that the diagram is so important because you want to find the given, you want to find something that they ask, but first of all, in order to use the chain rule, you need to draw a diagram. All right, so let's look at question 31.1 first. Question 31.1, I have W. Well, W equal to xy plus yc plus cx, and then x equal to r cosine theta, y equal to r sine theta, and c equal to r theta. So the diagram for question 31.1, this is W is a function of x, y, and z. All right, and x is a function of r and theta, y is a function of r and theta, z is a function of r and theta. So this is actually the diagram. So the question, well, we're gonna compute partial derivative of W with respect to r first, and then we're gonna evaluate at the given point after. All right, so we're gonna find that thing. Well, by the diagram that you have, W is here, R is here. So that means you can go from W to R via X or via Y or via Z. So this is going to be differentiate W with respect to X times curl X by curl R plus differentiate W with respect to Y by curl R, and then plus curl W by curl C times curl C by curl R. All right, simple like that. And then now you need to just differentiate. Differentiate W with respect to X. So W is here that I highlight in light blue. So with respect to X, so you're gonna get Y plus C. All right. try to go slow and you will see it. So differentiate x, y, so you get y. Differentiate y, c, you get 0 because you differentiate with respect to x. And then differentiate c, x, you get c. All right, and next we differentiate x with respect to r. So you get cosine theta, right? Because r cosine theta, you differentiate with respect to r. So you get cosine theta. And then plus differentiate w with respect to y, so you get x plus c. And then next you get sine theta, and then plus the last one you get x plus y and theta. All right, well, this is the answer you should get for differentiate w with respect to r. And then now you just need to evaluate at r equal to 2 and theta equal to pi over 2. So you can see that when x equal to when I equal to 2 and theta equal to pi over 2, you can solve for x, y, and z, right? Because, well, follow my highlighter here. So I use my green highlight to see, hey, this is I equal to 2 and theta equal to pi over 2. So I can plug in back to solve for x, y, and z. So when I equal to 2 and theta equal to pi over 2, x gonna be 2 times cosine pi over 2. That makes sense? Which, cosine pi over 2, this is 0. So actually x is equal to 0. And then y equal to r times sine pi over 2, which is 2 times sine pi over 2, which is going to be 2 times 1, right, which is 2. And then c equal to r times theta, which is 2 times pi over 2, which is pi. All right, so, well, when I equal to 2, theta equal to pi over 2, you already solve, and then you get x equal to 0, y equal to 2, and c equal to pi. Make sense? And then after that, you come back to the original question and you plug in the numbers. So you get 2 plus pi here times cosine pi over 2. And then plus x plus c here. And then sine pi over 2. And then plus 0 plus 2 here. And then theta is pi over 2. All right, so, well, the first term here you get 0, right? Because cosine pi over 2 is 0. The next term here you get pi, right? Pi times sine pi over 2, which is 1. So pi times 1 is pi. And the last one, 2 times pi over 2, so you get pi. Well, the answer is going to be 2 pi for this question. Sounds good? All right, so let's move to the next one, which is differentiate w with respect to theta. All right, I'm going to use the same diagram here, but I'm going to just copy to the next page. All right, now we have what we want is differentiate w with respect to theta, right? So that's well, I'm gonna get differentiate w with respect to x times curl x by curl theta, and then plus w by y, and then y by theta, and then w by c and c by theta. All right, simple like that, because you have this one the first line, this one the second line, this one the third line. Oh, and you just do as before. So you differentiate w with respect to x, so you get y plus c. And then now you differentiate x with respect to theta, so you do not need to differentiate r. And then you differentiate cosine theta, so you get negative sine theta. Right, and then the same thing, so x plus c, and then and then you differentiate sine, you get cosine, and then the last one is x plus y times r. All right, now you evaluate differentiate w with respect to theta at the point I equal to 2 and theta equal to pi over 2. So the answer is going to be, well, of course, you're going to get x equal to, remember from last time, x equal to 0, y equal to 2, and z equal to pi. well, you need that to plug in. And then once you plug in, you're gonna get to plus pi times negative 2 here times sine pi over 2, and then plus 0 plus pi, and then 2 times cosine pi over 2, and then plus 0 plus 2 times 2. Alright, this is what you get at the end. So 2 plus pi times negative 2, and then plus 0 here, because cosine pi over 2 is 0, so you're gonna get 0 here anyway. So this term gonna be that, and the last term gonna be number 4. Well, at the end you're gonna get negative 4, negative 2 pi, right, plus 4, and that answer is negative 2 pi. All right, this is how to do question 31.1. Easy? Well, it is supposed to be easy, as long as you set up the diagram correctly, so you can do this question easily. All right, so I'm gonna skip question 31.2, but I will give you the answer. So if you wanna check the answer, here is the answer for you. So question 21.2 here that I highlight in light blue here. So the answer for this question is curl C by curl S. This is 1582. Differentiate C with respect to T. Here you get 3164, and differentiate C with respect to U. So you get negative 700. Well, the number looks massive because you plug in S equal to 4, T equal to 2, and U equal to 1. So once you plug in, you should get this number. Well, again, if your answer does not match with me, let me know so I can fix it for you. Sounds good? All right, we need to save time because otherwise the clip will be too long. So the next one, example 32. So we now move to the question that asks you to combine the chain rule and the second order partial derivative. So let's do that. So we have c equal to fxy, x equal to that, r squared plus s squared, and y equal to uh, 2rs. Well, the question asks you to compute the second order derivative, you know, uh, with respect to that notation. Well, we're gonna look at that notation in a little bit. So first of all, we're gonna draw a diagram. So c equal to x, y, c is a function of x and y, x is a function of I and s, y is a function of I and s. Well, let's look at this notation together. Well, let's see if you can recall that. So co square c by co r co s here. So the notation here means you need to differentiate c with respect to x first, and then after that you differentiate with respect to r after. So keep in mind that the notation is so important. So this notation means you have to go by s first and then by r after. Does it make sense? Well, the notation that you have here, you read from right to left. So that means you're gonna do the first time you're gonna do differentiate with respect to s first, and then to differentiate with respect to r is the second order. All right, so we're gonna start by computing differentiate c with respect to s first. So I'm gonna expand the thing that I highlight in green here into the bracket. Sounds good. What I have here, I am going to differentiate c, which is on the top level, with respect to s. So what I have differentiate c with respect to x, and then differentiate curl x by curl s, and then plus curl c by curl y, and then curl y by curl s. Well, what I just did here, the thing that I highlight in green, this is just the chain rule. By looking at the diagram, I just use the chain rule here. I didn't do anything other than that. And then after that, well, let's simplify a little bit. So because you know that x equal to r squared plus s squared, so basically you know how to differentiate x with respect to s, so you get 2s, and you know how to, oops, sorry, must be plus, and then differentiate c with respect to y, which you don't know how to differentiate, huh? Because there is no explicit form of that. And then curl y by curl s, so you're gonna get 2r, right? Because differentiate y, which is 2rs with respect to x, with respect to s, so you get 2r. All right, next we're gonna just split this thing into two terms. So differentiate with respect to r, and then you get curl c by curl x times 2s. So I start doing this thing because I'm gonna, well, let me finish this thing first. All right, so the reason why I do this because, well, I just want to make the computation much simpler. So I'm gonna expand the differential operator inside here. So that means I separate this thing into two pieces. So differentiate with respect to r of the first term and differentiate with respect to r of the second term. I'm gonna call this thing number one, I'm gonna call this thing number two, and then we're gonna do two terms separately, and then we're gonna add them up together as we did in lecture. So we're gonna say that this is the term number one, this is the term number two. So let's see. All right, so start from the term number one here. Well, I have differentiate with respect to r of that term. You can see that this thing 2s does not depend on r. So this is actually the constant, so we can pull out 2s. Well, because it does not depend on r, right? It does not depend on r. Well, I can pull out that 2s. Well, the thing is that here we have curl c by curl x, and then I want to differentiate that with respect to r. Well, curl c by curl x is still a function of x and y. This is still a function of x and y, right? Because, well, curl c by curl x is going to be the term that still on the top level here. You want to differentiate with respect to r, so that means you have to expand it one more time. So you're gonna get, well, let's see, 2s here, keep it over there. You differentiate the thing that I highlight in yellow with respect to r. So you're gonna get the thing that highlight in yellow, curl c by curl x. You're gonna use this thing differentiate with respect to x first, and then curl x by curl r, and then plus that thing differentiate with respect to y, and then curl y by curl r. Well, if you cannot follow me here, so let's take a step back. This is not simple, but you can see that, well, keep the thing that I highlight in yellow as something that you know in the box here. If you want to differentiate something in the box there with respect to r, so you have to differentiate that thing. You know, the box thing going to be on the top here if you look at the diagram. So if you want to differentiate that thing with respect to r, so you can differentiate that thing with respect to x first, and then multiply curl x by curl r. So the same thing, you differentiate that thing with respect to y, and then multiply curl y by curl r. And then you add them up together. This is by the chain rule. And then this is your answer for this part. Well, you can simplify more a little bit. So this is 2s. This is the second order differentiate c second order, and then differentiate with respect to x two times, and then time curl x by curl r, which you know that this is 2r, and then here gonna be that notation, and then differentiate y with respect to r, so you get 2s. All right, this is going to be the answer for the first term here. So I'm gonna simplify more, so I get 4rs times that, and then plus 4s squared times that. All right, that's the first term. Well, let's do the second term. Well, it is going to be a little bit tough on the second term here. All right, the second term here, I'm gonna copy that term. All right, I have that. Well, now you can see that you can pull out number 2 there. But the thing is that, well, you need to use the product rule here, right? Because it's gonna be something that you need to differentiate with respect to R. Well, you have to use product rule here. So we're gonna use the product rule. So it's going to be 2 times, well, this is a product rule. You have something multiplied together, so you're gonna get keep, well, I'm gonna go slower because this is a little bit complicated. So I'm gonna label the first term here as the green one. The second term here I'm gonna label as the orange one. So what are you trying to do? You're gonna keep the green fixed and then differentiate orange, right? And then keep the orange fixed and then differentiate the green one and then add them up together. That is the product rule. All right. Here you're gonna get that the green thing, and then by the product rule you just keep the green thing and then differentiate with respect to R of the second one, and then plus keep the second one and then differentiate the green one. This is by the product rule. All right, so let me label that thing for you. Well, this is actually by the product rule. Well, because you know that differentiate uv with respect to x, so you get u dv plus v du. All right. Not that hard, it's just complicated because of notations. Chain rule is not hard, it's just complicated because of notation. Alright, so let's simplify a little bit more. So you have 2 times curl C by curl Y. Differentiate R with respect to R, here you get 1. And then plus R. And then, well, that term is a little bit tough, the last term. Alright. At this point, well, I'm gonna multiply number 2 back over there, so you get 2 times curl C by curl Y. And then I have plus 2R differentiate with respect to R curl C by curl Y. Alright, that is what I have. Well, you know, the only term that I need to compute is the last one that I highlight in yellow here. This is, I still need to compute that thing, but other than that, I'm done. Right, other than that, I'm done. So to compute that term, we're going to use the same idea as before, because we know that, well, curl C by curl Y is on the top level. Here is a function of x and y, and x is a function of r and s, right? Y is a function of r and s. So that means, well, what we get is, well, I'm going to keep everything in the front fixed. And then the last term that I highlight in yellow here, this is going to be differentiate the thing that I have, curl C by curl Y with respect to x first, and then curl x by curl R, and then plus differentiate with respect to y, the thing I have over there, and then curl y by curl R. All right, hopefully you can follow that. This is the thing that I have in the box here on the top level. So I want to differentiate that. So I differentiate with respect to x first, and then multiply curl x by curl R, and differentiate with respect to y, and then multiply by curl y by curl R. Sounds good. And then next one, I simplify a little bit more. So I have that thing, notation gonna be curl square C by curl x curl y here, and then differentiate x with respect to R here. So you get, well, let's come back to that. Well, we have x equal to R square plus s square. So you're gonna get 2R, and then here the notation gonna be like that. And then curl y by curl R. So this is going to be 2s, 2R here, sorry. All right, now let's simplify a little bit more. So you get to that, and then 4r squared code c squared y by code x code y, and then plus 4rs code squared c by code y squared. All right, that is the clean form of number 2. Well, once you add up number 1 here and number 2 over there, once you add them up together, 1 and 2, well, that will be your answer. So the final answer is 1 and 2. Add them up together. Well, that is all.